Hello guys, welcome you all for this end-to-end session of AIML, where you guys gonna learn everything that you guys need in order to become a successful data scientist. Hope you guys are enjoying. We are enjoying a lot, and we are learning a lot each and every day. Hope the same thing for you guys. So today it's gonna be a continuation session of previous session where we have discussed the deep learning metrics, how to evaluate the deep learning models. Today it's a continuation of the things. So today we're gonna see some more metrics, and we're gonna conclude this deep learning part. Okay, I'm just waiting to do it. Okay, so yeah guys, so as always, please make sure that if you guys coming to the session, please make sure you guys watch all the previous session videos so that you can have a better understanding of what we're going to talk and what we are good doing. Okay, so and one more thing, please subscribe to our channel, because like every day we're going to post a new video. So if you guys subscribe and press the bell icon, so you can get a notification whenever we just upload a new video. Okay, and one more thing, we are having 3000 plus quizzes which are available in our YouTube channel. Guys, please go there and then attempt it. If you have any doubt, just come back to this session and watch the session, and you get a clarity, and then just go there and attend the things. Okay, so yeah guys, without wasting any time, let us jump into today's session. As I mentioned before, today is a continuation of evaluating the deep learning models. Okay, what we are having for today, first thing we are having is confusion matrix and its interpretation. Okay, I hope like you guys already know about it. If you guys are following us, we have discussed this in the machine learning part itself. Let us discuss one more time. Okay, confusion matrix and its interpretation, guys, I will say it's like a major thing. Whenever you go for any kind of evaluation, confusion matrix is a major thing. Okay, so true positive, false negative, and true negative. Let us discuss about this. Okay, true positive, correctly predicted positive instance. False positive, negative instance incorrectly predicted as positive. False negative, positive instance incorrectly predicted as negative. True negative, correctly predicted negative instance. I hope like it will be confusing. I truly believe it is confusing. Okay, let me put it in the simple way. Okay, let's have a particular use case, that is the person has a heart disease or not. Okay, 0 1 0 1, let's consider in that manner. Okay, now 0 0, that means the person doesn't have the heart disease in the data set, and model is also predicting the person doesn't have the heart disease. That is called as 0 0, that is true positive. No heart disease by the data set, no heart disease by the model. Now, moving on to the false positive, 0 1. That means the data set says the person doesn't have the heart disease. Model says the person has the heart disease. That is called as false positive. Okay, now moving on. Here 1 and 0. 1 and 0 means in the data set we are having the man has the heart disease. The person has the heart disease. But our model is predicting the person doesn't have the heart disease. That is called as false negative. Moving on, true negative means 1 1. That means the data set says the person has a heart disease. Model also says the person has the heart disease. Guys, that's it. Okay, consider in this manner: 0 1 0 1 0 0 0 1, sorry, 1 0 1 1. Okay, I hope like you guys are understanding, right? You need to put 0 here, 1 here, 0 here, 1 1 here. Okay, so 0 0 this cell, 0 1 this cell, 1 0 this cell, and 1 1 this cell. Okay, in this way you can interpret this confusion matrix. Guys, it is very important. If you guys stuck anywhere, or if you guys need any kind of insight from this, please make sure, don't hesitate, just put it in the comment section. We'll take up and we'll solve your doubts. Okay, let's move on to the next slide. What we are having next as a matrix, let's move on. Okay, cross validation, guys, this is something which is something different. Okay, let's understand this. Okay, cross validation technique, it is also one of the metrics in order to evaluate the deep learning models. Let's move on and let's understand this. Okay, yeah, k fold divides the dataset into k fold, training on k minus 1 fold and evaluating on the remaining fold. For example, consider we have trained our model and we're gonna evaluate our model. We are having 100 data. From that, I'm training with 60%, that is 16 data, and evaluating with 40 data. That is called as k-fold. We are having 60% for training and 40% for testing. Next. Stratified curve fold ensures the class distribution in each fold matches the overall dataset distribution. That is, for example, we are having a classification problem. Okay, I'm going to classify dog and cat. We are having an image of dogs and we are having an image of cat. 50 images for dog and 50 images for cat. Now, when I train with 50 image. I test with 50 image. For training, I need to have a equal distribution of both the categories. For example, 25 images of dog, 25 images of cat, I need to train. This is called a stratified K-fold. We are having 50 data for training or 60 data, consider 60 from 100, we are having 60 data for training and 40 data for testing. While training, in the 60 data, we need to have for our problem statement of classifying dog and cat, we need to have 30 images of dog and 30 images of cat that is equally distributed. That is called a stratified K-fold. While training, we are just equally distributing the classes and training with 60% of data for our scenario, and 40% for testing can be anything. Okay, it can be 20%, 20% or 20, 30, 10, anything. Okay, it is not a problem. But during training, you should have a equal distribution of classes. Okay, I hope like uh, that is a simpler thing that I can explain. Moving on, we are having leave one out. Okay, this is another strategy how to evaluate the model. Leave one out means uses a single observation from original samples as a validation set. Consider we are having 100 data. We use 99 data for training, only one data for testing. Similarly, this is for the first step. Consider we are having 100 data. We use one for testing, all other are training. Next step, we use the second data for testing, all other are training. Next step, we are using third data for testing, all other are training. Like that, we will move on until we reach 100 because we are having 100 data, right? In this way, we can evaluate the model. Okay. Hope you guys are able to understand. This is how cross validation helps us to evaluate the deep learning model. Okay. Let's move on to the next slide. Okay, handling imbalanced data set, guys, this is very very crucial. Whenever we are having for a real-time situation, we doesn't gonna have a ample amount of data that we are expecting. Okay, that is sure, guys. I will just bet you like we're not gonna get 100% data that we need. So we need to handle this imbalanced data set. Okay, let's see what are the things that we are having. Oversampling, duplicating instance of minority class to balance the data set. For example, we are having a data set where my problem statement, I need to just go for the classification of dogs and cats, where I'm having 100 data. From the 100 data, 70 images are related to dog, only 30 images are related to cat. Now I'm having a oversampling technique where how I can do means I have a minority class, right? That is cat is only 30. What I can do means I can just project that to 70 by using data augmentation or kind of a technique, so that both the classes will be balanced. 70 dogs, now 30 to 70 becomes cat, so 70 cats, so the class is balanced. Now there is another technique called as undersampling, removing instance of majority classes to balance the data set. We can do vice versa, right? We are having 70 images of dog, 30 images of class. During oversampling, we have increased the minority class, that is 30 to 70, the cats. Now, undersampling means we have 70 images of dog and 30 images of cat, right? We just remove the remaining things. That is, let's have 30 images of dog and 30 images of cat. Now also the class is balanced, right? In this way we can do. Next, class weighting, that means assigning higher weightage to the minority classes during the model training. Okay, perfect. Consider we doesn't do anything. Okay, we are having the data as it is, that is 70 images for dog and 30 images for cat. Leave it as it is, but there is an imbalance, right? How you can do means we can apply the class weighting. That means we can go for more iteration of training for the minority class, because we are having only 30 samples for cat, so the model doesn't able to predict that much as is compared to the dog, because dog we are having 17 images. So what we can do means we can go for more number of training for the minority class, that is here related to cat, that is 30 images. We can use more training so that it becomes a balanced training for both the classes. Okay, I hope like this is a simple way of explaining this handling missing data. So hope you guys are understand. Okay, let's move on to the things. Okay, yeah, so I hope like we're gonna see the best consideration and practical consideration and best practices how we can do it. Okay, so first thing, we need to choose the appropriate metrics. Okay, select the metrics that align with your project goal and data distribution. Guys, this is very very important, guys. Consider I'm going for something like a classification task, that is dog or cat prediction, right? Here I need to go for something like related to the metrics which is related to classification, that is precision, recall, accuracy, confusion matrix, like those things. When I'm going for something like stock market prediction, I should not, or something like, putting in a simple way, we are having R and N, right? Future prediction. You guys should not go for accuracy because it is completely different. It is a forecasting or prediction kind of thing, where you need to go for some metrics such as like auto score, mean square error, like those things you need to go. So we need to specify, or we need to choose the exact metrics that we need to evaluate our model. Okay, that is very, very important. Next, monitor model drift. Regularly evaluate models to detect performance degradation over time. Okay, whenever we are implementing an RNN model, right, we will work on the past data. Based on the past data, we will predict the future for now. So in the future cases, there may be the possibility that this uh, past data will not work. For example, there is a climatic condition, right? Like mostly we will be having a rain in our country. We will be having a rain at the end of the years, but the climatic conditions is completely changing, man. It is getting the start of the year also, middle year. So what I'm trying to convey is like, there may be the drift in the model or in the real world environment which is not exist in the past, because consider we have trained our data for the previous year and we are going for the prediction of weather for the current year. It will work for the current year, but for the next year, which we are, if we go for the same knowledge of 2 years before, it will not work, because for the current year there will be something different in the climatic condition will happen. So we need to keep on monitor the model and we need to shift it based on the real world scenarios. Okay, next, leverage cross validation. Ensure robust model evaluation and minimize the overfitting. Okay, that is, we need to apply the evaluation metrics as well as possible so that we can reduce this underfitting and overfitting scenarios. Okay, I hope like you guys already know about underfitting, overfitting, right? We have taught you nearly 25 plus times. Let me explain one more time. Underfitting means what? We have trained our model, the model doesn't works for the training data itself, then it is called as underfitting. Overfitting means we are trained our model works 100% for training data, but 0% for testing data. Then it is called as overfitting. Okay, I hope like this is the 26th time we are explaining. Okay, so yeah, guys, this is all about metrics which is used to evaluate the deep learning models. Guys, actually, in this slide, we are just ending. I will say we are just wrapping it off the deep learning concept, guys. It's great. We have completed deep learning, guys. If you guys are to this level, I'm just appreciating each one of you who are just completed with us. Okay, we have completed deep learning, guys. What are the things that we have completed till now is like, we have completed, we have played with data enough, where we have learned about Python, SQL, and then data visualization technique, EDA, everything, guys, end to end in the data in data science. Whereas we have moved on to machine learning in data science, where we have discovered you what is machine learning, what are the types of machine learning, where we have discussed supervised, unsupervised, reinforcement learning, classification, regression, and then clustering, dimensionality reduction, association rule, different things, and reinforcement learning, and we have wrapped it off. Today we are wrapping it off deep learning, where we have started with what is deep learning, how deep learning differs from machine learning, what are the things that we are having considered. Like we have discussed about dense layer, ANN, CNN, RNN, and GAN. Okay, generative adversarial network. Last previous two sessions, like we have ended up with transfer learning, everything. Okay, and today we have just discussed about the best practice how to evaluate this deep learning model, guys. Okay, actually we have covered 3 modules, guys: playing with data, working with machine learning models, and working with deep learning models. Okay, happy? I'm very, very happy to like discuss these things. Okay, so in the next session we're gonna introduce you to the new module. Okay, that is completely like you guys gonna enjoy it. Okay, that is which is very, very relatable to real world situation. Like you guys are thinking about how a self-driving car works, right? You're gonna see the magic that is a black box behind every self-driving cars, a kind of things. Okay, that is, we're gonna learn about computer vision, guys. Okay, so coming modules or coming session is going to be completely about computer vision. Today we are just wrapping it off the deep learning concept. Okay, we will all meet in the new session which is completely related to computer vision, where we're going to see the theory, concept, black box, everything, and we're going to work on some coding part, and you're going to enjoy nothing like before, guys. Okay, so yeah, That's all about today's session, guys. We are wrapping it off. As I'm just mentioning again, we are wrapping it off the deep learning concept. If you guys have any doubts related to the things related to deep learning or machine learning or working with data, please ping us in the comment section. We'll take up and we will solve your doubts. Okay. So yeah, that's it from my side, guys. Hope you guys have enjoyed, and we're gonna start a new like a new session like related to computer vision in the next class. So yeah, guys. Until next session, bye, guys. Keep learning, keep happy, like learn what are the things that okay. And moving on, like please make sure you guys attend. We are having 3,000 plus quizzes in our YouTube channel. Please make sure you guys go and attend it. So yeah, that's all about from my side, guys. Until next session, bye, guys. Take care. We will all meet in the next session. Bye, guys.